Recording in progress.
Good evening, teacher.
Good afternoon.
Good afternoon, teacher.
It's the afternoon here. I don't know, for some of you it may not be the afternoon. Yes?
Yes, Miss.
Okay. Right. Yes, could you please turn on the videos, all of you? Yes, Situli and Shamla. Okay. So once again we are going to start the session. So this time we will continue, right? So the objective is mainly to complete the edXL curriculum, that the lessons which are supposed to be completed, but I am not straightly bound to the book, because we have to gain some extra information. Whatever the curriculum you study, I want to give the knowledge in science, right? So I think that would be helpful for all of you, rather than just discussing the topics in your book. We'll just use the book as a framework, and we will discuss the topics as a common, right? So we will do certain activities. I will explain the lesson content. So I will give you certain activities on the board, and on some of the days you will receive activity sheets. So before the session I will share them with you, so you will have to take a printout and be prepared, right? Uh, then what should I say? What else do you want to know about the method that we are going to conduct? Yes, and about the presentations, right? Every day, in every week, I will assign 2 students to make a presentation, right? On the coming week, you have to present it to the class, and you have to ask certain questions from the audience, right? The presentation should be restricted to maximum 3 to 5 minutes, right? So within that period, you have to present on the given topic, and you can ask questions from the audience. Okay, so we will do some more activities in the coming lessons. So today I thought of discussing about mixtures with you, mixtures and separation techniques. We will start from this. So before we are going to discuss about mixtures, we should know about matter. So you have learnt about matter, right? Yes, Situli, I know about Ayan, Tuan, I know. Then Senyut, okay, Kemit, well known. Sanaya, okay. Shamla, can you turn on the video, please? Situli, are you from the same school? Lyceum?
Yes, teacher.
Okay, right. So before your assessment, I think you are going to have the final assessment on July, right? Before that, we will revise everything by using certain worksheets for all of you, right? Is it okay? Is that method okay for all of you? Is there any suggestions? If you have any suggestions, you can come up with those. You can talk, you can ask questions, anything, right? Once I am explaining the things also, if you have any question, just raise your hand and I will give you the chance to ask, right?
Okay, miss.
I like to have this more or less discussion rather than lecturing mode. I like to have this as a discussion, right? You can just come up with your ideas. Okay, Hari. So what do you know about matter? Yes, can give me the
Teacher,
answers. Yeah.
matter is everything around us, and matter is everything. That means we are even made of matter.
Right.
Almost everything means even the world is made by matter. Even the universe is made by matter, and everything is matter, and everything is also matter, and
Isn't
everything
there
around us.
anything else except matter? Isn't there anything else? Yes, the others?
Teacher, energy.
That's energy. Yes, Shamla. So yes, Kemith told about matter, that almost all the substances are made out of matter, right? So we can divide the things around us. Things around us can be divided into two main categories, right? As Kemith and Shamla told, one type is matter and the other is energy, matter and energy. So what's the difference in between these two? Yes, what is the difference in between matter and energy, if you know, Ayan? As you feel, it's okay. Anyone else? Tuan?
Excuse me, Miss.
Yes, Tuan.
Miss, in our school, me and Ayan didn't learn this yet in biology.
You haven't learned about this lesson? You haven't learned?
Yes.
Okay. Okay, then let's learn. Senyut, any idea? No? Sonaya? What's the difference in between these two?
I don't know.
You don't know. Situli?
Teacher, can I?
Yes, we'll ask from Situli first, then I will give you the chance, Kemi. I know always I get answers from you. Yes, Situli? Manahan kyan bude? It's okay if you go wrong, it's okay.
We need energy to move something, like move or do something, and make
Yes.
everything is made from matter.
Everything else made out of matter. So energy is needed to do the work. Yes, Kemi, what's your answer?
Teacher, energy and matter comes in a whole different ways, teacher. Energy can be exerted, energy can be created, but matter cannot be created. And even matter is sort of, not sort of an energy, matter is a thing. Matter is sort of thing. And energy is sort of an thing that makes the matter and matter.
Okay.
Matter being and matter.
Yes. So matter means, now simply if we take what matter is, now think of a box containing bowls, right? A box containing certain bowls. So there is a maximum number of bowls that can be stored inside the box, right? There is a maximum number of bowls that can be stored inside the box. What does it mean? The bowls, each bowl occupies a particular space, right? Now each bowl occupies a space inside the box, right? So things that occupy space, right? Things that occupy space and having a mass are known as matter, right? Things that occupy space. Now think of the students in a classroom. So there is a particular number of students that can go inside the classroom, that can stay inside the classroom, because even the students occupy space. They also belong to matter, right? Then if you take a bag which is filled with rice, we'll say, right? So that occupies space and it has a particular mass. We say that it is 1 kilogram. Or if we consider our body mass, we can say 40 kilograms likewise. They have a particular mass. Each and every object has a particular mass. And we can say the things that occupy space and having a mass are known as matter, right? Things that occupy space, things that occupy space and having a mass are known as matter. Is that clear? Right, that is about matter. Then there are three states of matter. Now if you have a water bottle close to you or a glass of water, right? So that water occupies the space inside the glass, right? Water also belongs to matter, right? Then if we think about our surroundings, though we can't see, there are so many gases, right? There are so many gases surrounding us, right? So these gases also occupy space. Do you believe? Now, when we blow air into a balloon, that air occupies the space inside the balloon. So, air also comes under matter. Air also
Teacher.
comes under matter. Yes?
And teacher, and the best example is teacher, when we take normally our gases in our home, when it's empty, teacher, it is around like 2 kilograms. And when we fill the gas and when we check, it is about like 12. No, so teacher, that means when gases is also putting into the sort of an thing, or when it's compressed, even it even contains sort of weight.
Yes. Yes, the weight and mass are two different things. But as you told, when the gas cylinder is filled with gas, LP gas, it has a particular mass. They mention it as 12.5 kilograms or 5 kilograms or 2.5 kilograms. Likewise, they mention the mass. But when we have consumed the gas inside, the mass of the cylinder becomes less. Right? The mass of the cylinder becomes less. Right. Okay. So there are three states of matter. Three states of matter. Three states of matter. What are the three states then?
Solid, liquid, gas.
Solid state, yes. Liquid state and the gaseous state.
Teacher, can we take sometimes, I've heard like the plasma.
Plasma,
can we
yes.
take it?
That does not come under each of these categories. That is a different state. But here we are not going to discuss about the plasma, right? We are discussing about basically matter and energy. Hari. So you can just take down this chart. We will fill up the other side after writing about this. We have to mention so many other things related to matter. Okay, start. You can have a very clear and nice note. So you can summarize the things when your exams are close by.
Focus. Expose okay. Come in.
ඔව් ඉතින් දුවට කිව්වා යන්න කියලා අම්මලා එක්ක. ඉතින් බෑ කියලා.
One teacher.
Well, miss.
Okay. Hi. Then what is energy? Now, if matter occupies space and have a mass, what about energy? Yes? Energy does not occupy space. Now I have illuminated this classroom by using lights, right? So, but the light does not occupy space inside the classroom, right? And you can hear the sound, but the sound does not occupy space. It is a type of energy, right? Then we make use of electricity. So electrical energy, it does not occupy space. When electrical energy passes through these wires, it does not have a mass, right? Therefore, electrical energy is a form of energy. Then when the water is flowing, that flowing water has a particular energy, right? Flowing water is used to rotate the turbines, right? Because it has a particular energy, right? There are different forms of energy, and then we can say energy does not occupy space, does not occupy space, then does not have a mass, does not.
Teacher, but energy needs an action.
Yes, energy is needed to do a particular action. Energy is needed to do the work. We define the term energy as the ability to do the work, right? We are able to do work. Now, we as human beings, we as organisms, we got energy because of the food that we have taken. That food is stored in the form of chemical energy in us, right? Chemical energy in us, right? Hi, so you can say the ability to do the work is energy. Energy is the ability to do the work. Right? So you can give examples for different forms of energy. Different forms of energy. So out of these two, in this lesson, we are going to discuss about matter, right? Different forms of energy. We can say light. Yes? Give me examples, all of you.
Fossil fuel energy.
Energy of fossil fuel means, once again, in fossil fuel, in any type of fuel, we have chemical energy, right? Fossil fuel, crude oil, then LP gas, in this coal. In this we
Teacher,
find chemical energy.
thermal energy.
Thermal energy or heat energy or the thermal energy. Heat.
Wave energy.
Energy of waves, sea waves. Yes. Kianta.
Radiation energy.
Energy
Solar
of
energy.
radiation.
Electrical energy.
Electrical energy. Yes, Senya.
Energy.
Nuclear.
Nuclear power. Yes. What else?
Kinetic energy.
Kinetic energy.
Solar.
Solar energy.
Gravitation potential energy.
Gravitational potential energy. Potential energy is of two types: gravitational potential energy
Elastic
and
potential.
elastic potential energy. Yes, you know.
Teacher,
Yes.
teacher, teacher, in neurons even you have a specific energy, right?
Neurons. Yes, when the
Okay,
neurons transmit the nerve impulses, they are taken as an electrical signal, right? Electrical signal. And that happens because of an ion exchange mechanism. So you can say potential energy, as you told, potential energy, kinetic energy, right? Kinetic energy. Then you mentioned about solar energy, right?
Radiation.
Radiation, energy of radiation, right? Hi. Then you mentioned about the energy of the waves, sea waves, right? Hi. So there are different forms of energy and there are different sources of energy. Sun is the main source of energy we have. We'll discuss about energy later on. So today we are going to concentrate on matter. So these are the three physical states of matter.
Okay.
Done? All of you?
It should be write the energy part
Yes,
too.
yes, you have to write.
Is I'm still writing.
Tuan and Ayan both are from the same school, right?
Yes,
Yes.
miss.
Okay. Senyat, where are you from, Bute?
Kata.
Yeah, you're from Kata, okay. Then
Miss,
Sanaya, your cousin brother is not here, no? No. Right. What's his name? He's Sadi. No. He's Pulmet. Yeah. Have you all finished?
Miss.
Is writing the exam.
Okay. Sadisha, good
Yes, teacher.
afternoon.
Good afternoon, teacher.
You got late, no?
Yeah, teacher, I messed up the timing.
Okay. So next time, just remember the time, right? It is 2:30 p.m. From Sri Lankan time, right?
Yeah.
Okay, Sadisha, we started to discuss about the things around us. We just classified the things into matter and energy, right? So I will share the
Okay.
recording. So once I share the recording, you can just go through the initial part of our lesson. Right? You can
Okay, teacher.
leave a page and start from the next note.
Okay,
Done,
teacher.
miss.
Okay. Kemit, have you finished? Shall I clear the things?
Teacher almost in the
Almost done. Okay. Hi. Then, so here we have classified matter into three categories: solid, liquid, and gas. That is based on the physical state. So I will give you certain examples. So you have to mention whether it is a solid, liquid, or a gas, right? You have to put S for a solid, L for a liquid, and G for gas. Right? Then we will discuss about the differences in these three states of matter. Okay, this is question number 1. Q1 for today. Yes, Ayan, any problem with it?
Should we write the question?
Yes, you have to write the question.
Okay.
යනවලුද? අම්මලක් යනවලුද? ඈ? නෑ ඔයා කන්න එපා. So you have to say whether these are solids, liquids or gases. You have to put the first letter in front.
Done, teacher.
Okay. Shall we check then?
No, miss.
Not yet.
No, miss.
Okay, I will give you another 2 minutes then.
Thank you.
Okay, shall we discuss? Enough. Hi. What about carbon dioxide? I need the responses from all of you.
Yes.
Yes.
Gas. Right, carbon dioxide is a gas. Milk,
Liquid.
liquid still. Sand,
Solid.
Solid. Milk powder?
Solid.
Solid. Though it is a powder, it is in the solid state, right? Oil?
Liquid.
Liquid state. Then gravel? What is gravel?
Solid.
Solid. Right. Oxygen?
Gas.
Plastic?
Solid.
Crude oil?
Liquid.
Coal?
Solid.
Coal is in solid state. Coal is used as a fuel. You may have heard about the steam engines which were used earlier, right? So in those they used coal as the fuel. By burning coal they generated heat, and by using
Teaching barbecue machines.
yes, nowadays even we use in barbecue machines, yes. So they heat coal, burn coal and generate heat. By using that heat, they just boil water. By using the steam, the engines are operated in steam engines. Right, did you
But
get
Miss,
all
it's not
10
good for
correct?
the environment.
Yes, teacher.
It's not good for the environment to
It's
burn
not,
coal.
yes. It causes certain environmental pollution, even this
Global
petroleum
warming.
oil. Yes, petroleum oil. By the refining of crude oil, we obtain them. These are also not that environmental friendly. Yes. Hari, did you get all 10 correct?
Yes, teacher.
Miss.
Then we will differentiate the three states of matter, considering having a particular volume, whether they have a definite volume and a definite shape, right? You have to complete this table, think a bit and just complete.
James.
Yes. But when you are not giving answers, please mute your microphones. Otherwise, the background noises are coming. The three states of matter we are going to differentiate. So we'll do this together, right? And just draw the table, then we will discuss and complete.
Done, Miss.
Okay. So what do you think about the shape of a solid? Does it have a definite shape? Now think of the chairs, tables, books, pencils, pens that you have.
Yeah,
Yes.
it does.
Yes, they have a definite shape. A solid has a definite shape. It's definite. We can mention the shape. A solid has a definite shape. What about the volume of a solid? You are packing eggs in a container, or you are packing certain bricks in a given hole, we'll say, or a storeroom. So, do they have a definite volume? Or can you change the volume of a solid?
Yes, teacher. We can change the volume of a solid.
How? Can you give me an example?
Yes. By building it bigger. Small.
Example. Now you are given
Like
a brick.
teacher, now when we are making bricks, sometimes now the brick shape we can take it low. Sometimes we can take the bricks length lower, bit lower,
Yes.
or the width lower, and we can make the volume indefinite than the one that we made earlier.
Yes, but still the smaller brick has a definite volume. The larger brick has a definite volume, right? A solid has a definite volume, right? A solid has a definite volume. Now, if you are given a set of bricks, can you just change the total volume? Can you change the total volume of those? You can break them into pieces, but still the total volume will be the same, right? So
Yeah,
you can say solid has a definite volume as well. Has a definite volume. Right. Then what about liquids? Yes. What can you say about liquids?
teacher, liquid depends. Liquid is a dependent one. Liquid is a dependent shape of the container that it is in.
Yes. If we put
Doesn't have
the
a
same,
definite shape.
yes, if we put the same volume, you are given 100 milliliters of water. So you can put that 100 milliliters into differently shaped containers, right? Like this, differently shaped containers in the laboratory. So the same volume, but the shape is different. It takes the shape of the occupied space of the container, right? Not the whole shape of the whole container, but the occupied space of the container, right? It does not have a definite shape, right? So you can say no definite shape, no definite shape. It takes the shape of occupied part of the container. No definite shape. It takes the shape of occupied part of the container. Is that clear for you? I used small letters there.
Yeah.
Then what about the volume? Yes?
It has a definite volume.
Yes, Senya?
It has a definite volume.
It has a definite volume. It has a definite volume. We can say 1 liter, 100 milliliters likewise. We can express the volume of a liquid. Therefore, you can say it has a definite volume. It has a definite volume. Then what about the gas? Does it have a definite shape?
No.
No. Now, there are differently shaped balloons. Once we blow air into those, they will take the shape of that particular balloon. Right? It does not have a definite volume. No definite shape. No definite shape. What about the volume?
Teacher, we can't tell the volume, teacher, exactly, teacher, but when we compress the gas, though we can tell the volume, but it's not the volume, it's the amount of pressure or something.
Yes.
It's the amount of compressibility of
Compressibility.
that thing.
Yeah. Now you all know about the LP gas cylinders you all have seen, right?
Yes.
So imagine that you have kept an LP gas cylinder inside a room like this, right? Now there is LP gas inside the cylinder. There the volume of the gas is the volume of the
Yes.
cylinder, right? Now a leakage occurs. a leakage occurs from the cylinder. Then the gas will be spread throughout the room. Then the gas occupies the space inside the room. Then the volume of the gas is the volume of the whole room. Did you get that? So does a gas have a definite volume? Sidhuli, does a gas have a definite volume then?
No, teacher.
No. At the beginning, the volume was the volume of the cylinder. Then after the leakage, it is the volume of the whole room. Therefore, we can say a gas does not have a definite volume either. No definite volume. No definite volume. Right. This is how we can compare the three states of matter based on the shape and volume. So later on we will learn certain other things, other features of the three states of matter in order to compare.
Done, Miss.
Okay. Then before we move on to mixtures, I will share a video related to matter, the three states of matter. After that, we will discuss how can we differentiate matter further based on their composition.
Okay.
I will share the video.
Excuse me, teacher.
Yes, Kemi?
Teacher, if we take about slime, teacher, if we keep it in a good position, teacher, without like making any disturbance in that slime, teacher, if we give it, if we give that a shot in a speed way, teacher, it is a solid. And teacher, when we slowly put our hand in, teacher, then it's a liquid, teacher. And teacher, when we like squeeze, when it's doing like solid and liquid both. So teacher, what is that matter?
We call them as semi-solids, Kemi. Semi-solids. And there are semi-solid media. They have, even if we consider jelly-like substance, gelatin, jelly, those have properties in between solids and liquids, right?
States of matter for kids. You may not think about it a lot, but everything in the world, including you, takes up space. The food you love to eat, the drinks you grab to quench your thirst when you come in from playing outside, the desk you sit at in your room, the pet you love, the bed you sleep in, and even the air you breathe. All of it takes up space. Of course, it doesn't all look the same and feel the same, smell the same, or even behave the same. And some stuff that takes up space, like the air you breathe, you can't see or touch at all. We have a word to describe all the stuff in the world that takes up space. Matter. Matter is all around us, whether you can see it, feel it, touch it, smell it, or not. And that's what today's lesson's all about. States of matter. No, not states that matter. That's a geography lesson for another time. States of matter. Okay, so think about it. How many different ways can matter exist? Some matter you can hold in your hand, like a ball or a book. Some matter you can feel but you can't really hold on to, like water or soda. And some matter, like air or helium in a balloon, you can't see or feel or touch at all. So there are three different states of matter: solids, liquids, and gases. And it's pretty easy to tell them apart. I mean, you can't drink a solid, right? And you can't hold on to a liquid. And a gas, they're all around you. But you wouldn't even know it because you can't see them. You might be tempted to think that gases aren't as important as solids or liquids. But without gases, none of us would even exist. Do me a solid and think about the chair or couch you're sitting on right now. What's it like? Does it have a definite shape? Is it soft, hard, a little of both? Can you pick it up? Does it make a sound if you tap on it? What about the computer or device you're watching this video on? Or the bread you ate last time you had a sandwich? Solids are things you can pick up, hold, and feel the shape of. Solids always have a shape. They can be hard, smooth, rough, or soft. They come in all different sizes, from as small as a marble to as big as a mountain. And you can hold them in your hands if they'll fit. Now, let's talk about liquids. The most common liquid is water, but there are a lot of other liquids all around you. Ever had a bad cough and been given cough syrup? That's a liquid. So is vinegar, vegetable oil, chocolate syrup, and the cleaning fluids your parents might use to tidy up the house. The gasoline your parents put in their car or lawnmower? Yep, that's a liquid. So is the sweat that comes out of your body when you run around a lot. Of course, a lot of the liquids we just mentioned are partially water, but they're still liquids. So, can you tell me what all liquids have in common? First, they will always fill the bottom of a container if you pour them in, and they'll take the shape of that container as you continue to pour. They usually have a smooth surface. They can be really hot or cold or somewhere in between, and they don't have a specific size. A liquid like water can fill an entire ocean or the smallest crack in the sidewalk. Okay, now let's talk about gases. Gases are some of the most interesting of all types of matter because they're all around you, but you can't see them. A gas is invisible, has no shape or size, can fill any size container, and has no surface and moves around easily. Oxygen is a gas that makes up part of the air around you that you breathe in. Other gases in the air are nitrogen and argon, not to mention CO2 or carbon dioxide, which is a gas that you breathe out. Carbon dioxide gas gets absorbed by the trees around us. Other gases you might be familiar with are helium and propane. Helium is used to fill balloons, and since it's lighter than air, a helium-filled balloon floats upward. If you've ever seen your parents cooking barbecue on a gas grill, the gas they're using is propane. It kind of goes without saying, but certain matter is easier to go through than other matter. You can swim in a liquid more easily than in a solid. Ever tried swimming in a ball pit? And you can run through a gas like air much more easily than you can run through a liquid or a solid. Here's where the subject of states of matter gets even more interesting. Believe it or not, there's some matter that comes in all three forms. Think about water, for example. Most of the time you think of water as a liquid, but when you freeze it, what happens? It becomes ice, a solid. And what happens when water boils? Ever watched your mom cook a pot of pasta and see the steam rising from the pot? That's water as gas. Here are some other examples that you're probably familiar with. I'm sure I'm not the only one who's had to rush on a hot day to quickly eat an ice cream cone or popsicle before it starts dripping down my arm. When a frozen treat melts, it's because it's transitioning from a solid to a liquid. You can actually smell things turning from a solid to a gas too. Ever smelled mothballs from across the room? Those mothballs are a solid, but the smell hitting your nose, that's the gas that the mothballs are emitting. Same is true when you smell cookies baking or a candle burning. I don't know about you, but I prefer the smell of baking cookies to the smell of mothballs. So, there you have it. Now you're one step closer to understanding the matter that makes up all the stuff in the universe. Wasn't learning about states of matter a gas? Solid!
Hope you had fun learning.
Okay, that is about the three states of matter. Now we are moving on to classification of matter based on the composition. Based on what they contain, we can classify matter into two categories. Right? We'll see. So I will say classifying matter based on composition. Classifying matter based on composition. Right? So what do you mean by composition as you feel? Yes, Shamla and Situli, please turn on the video. What do you mean by composition? As you feel?
Long and long collection of words.
What is it, Kemit? I
A
didn't get
long collection of words.
composition. What they contain simply. What are the components in them? Right now we know that there are three states of matter: solids, liquids and gases. Now think of the food that you consume today. Right? So it is a mixture of a number of substances, right? When we consume food. Yes, Sanaya? Food is a mixture of different components, right? Even if you consider a tea or a coffee, right? Cup of tea, cup of coffee, milk tea, whatever, or some cordial that you have consumed, right? These are mixtures, right? They contain number of substances. So accordingly, we can divide matter based on composition. We can divide matter into two categories: pure substances and mixtures. Pure substances and mixtures, right? And mixtures. So what do you think? In our surroundings, in our day-to-day lives, do we meet pure substances or mixtures in abundance? Yes.
Teacher, mixtures, teacher, because pure substances are sort of rare, teacher, because pure substances are the molecular substance made by only by the molecular.
Yes. So most probably, as he told, most probably we experience mixtures. As I told you, the food is a mixture, right? We mix so many things together in order to prepare food. Then even the water that we consume, there are certain minerals dissolved in them, right? So we find distilled water as a pure substance which is available in the laboratory, distilled water. It does not have any other substance except water. But the drinking water that we consume, yes, they contain certain dissolved minerals, there are dissolved gases, right? So it is a mixture. Then the air surrounding us, it is a mixture of gases. Yes, there are nitrogen
Soil
as
is
the most
mixture of
abundant. Yes, soil is a mixture. Air is a mixture, nitrogen, carbon dioxide, oxygen. Then there may be pollutant gases. Then water vapor is there in the atmosphere. Dust particles may be there. Yes, Kemit?
Blood is a mixture.
Blood is also a mixture of so many substances. Yes, true. Then soil is a mixture. Then what else? The drinks that we make, these are mixtures. Even the medicine that we consume, right? These are mixtures, right? So the pure substances can be further divided into two categories, elements and compounds. Right, I will give you time to write, just listen. Elements and compounds. Can you give me an example for an element and a compound? Yes.
So for element teacher, we can get silicon,
Okay.
gold,
Right, all of
silicon,
you,
gold,
give me the answers. I will give you time to write. Don't write now. Just give me the answers.
Hydrogen.
Yes, Senya?
Hydrogen.
Iron. Gold. Iron. Chemical.
teacher, elements
Silicon.
are most probably teacher like they are
Copper.
elements.
Copper.
Teacher, mercury.
Mercury.
Almost.
Carbon.
Teacher, elements are solid, right? Most probably because
Not all of them. There are elements in all the three states.
I mean like most probably
Most
teacher like
probably, right. Mercury, then you told, I can't remember what was the carbon, you mentioned about carbon. Right. How many elements have been identified so far? Do you know?
108.
108. Yes. Nearly 110. Then compounds. Can you give me examples for chemical compounds that you know?
Carbon monoxide.
Carbon monoxide. Carbon monoxide. Carbon dioxide is there.
Copper sulfate.
Copper sulfate. Copper sulfate.
potassium permanganate.
Potassium permanganate. Yes. Potassium permanganate. So these are made out of elements, right? These are made out of elements. Okay. So matter can be divided into two categories, pure substances and mixtures based on the composition. Right, based on the composition. Then the mixtures, we can further divide the mixtures into two categories. Right. So these are, later on we will learn about them. For the moment we will just classify and keep. There are homogeneous mixtures and heterogeneous. Yes. You know them, right?
Yes,
Heterogeneous mixtures. We will discuss about them later on. Homogeneous mixtures and heterogeneous mixtures. Okay. Right. Take this down, then we'll move on to the next step.
Teacher, what are elements and compounds?
So elements. Here we have given examples for elements. So elements are pure substances which cannot be further divided. Like when we say carbon monoxide, Shamla, It contains two elements, carbon and oxygen, right?
Done, miss.
So mixed compounds are made out of elements. Yes. Yes, Pute. Do you want anything to ask?
Yes, I'm done.
Okay. Okay, Tuan.
Miss, it's Shehroz.
Okay, sorry. You want me to talk as Sheroz, right?
Yes, miss.
Okay, sure. Yes, Sanaya, have you finished? And Situli?
Done, teacher.
Okay,
Teacher, I'm also done.
okay. So what is a solution as you think? What is a solution?
A
Yes.
mixture of liquid and solid. Solid.
Yes, Situli says a solution is a mixture of a solid and a liquid. Right. So there may be two components. There can be two components in a solution. So they may be either solid and a liquid, or maybe two different solid liquids even. Okay, two different liquids, isn't it? Now when you are preparing cordial, you dissolve a concentrated syrup in water, right? Then both are in liquid state, right? But you obtain a solution. Then when you are making a sugar solution, you can dissolve, yes, sugar in water, isn't it? Then you obtain
Yes.
a sugar solution. Then what about a salt solution?
Salt and water.
Salt and water are mixed together. You make a salt solution. Right. Have you all finished? Shall I clear this?
Yes.
Kemita
Yes.
is still writing?
Still right.
No, miss, I'm also still writing.
Okay. So until they finish, those who have finished, you can have a 2-minute break. Then you can go and drink some water and come back within 2 minutes, right?
Miss, I'm fasting.
Okay, Sheroz.
Done, teacher.
Okay. So we'll wait until the others come after the break. We have another 1 minute. Okay. Have you all come back?
Yes.
Yes.
Okay. Now we will discuss about a solution. So you already told me about solutions. Solutions. So there are two main components in a solution, right? One is known as the solute, right? One is the solute. Then the other one is known as the solvent, right? That is the solvent. When these two are mixed together, we can come up with a solution, right? Solute and solvent together, it ends up with a solution. Solution. Okay, so we'll give certain examples. What is the best solvent that you know? Yes, what is the best solvent?
Salt.
Water?
Water. Water is
Oh,
considered
solvent. Okay.
yes, water is considered to be a universal solvent because most of the substances get dissolved in water, right? Now consider our body. There are so many reactions happening inside our body. So if we consider our body mass, majority of consists of water, right? If we consider our blood, a higher percentage of it is water because so many
Teacher?
substances are dissolved in it. Yes.
Teacher, the specialty is teacher. Water is used. Normally, water is used in every sort of drinks to lower the alkalinity. Not
Yes,
alkalinity, acidity.
acidity. Right. So many substances get dissolved in water because water has certain properties in its chemical structure. Right. Later on, you will learn about the structure of a water molecule. So, number of substances can be dissolved. Even the plants absorb water along with the dissolved minerals. The plants are capable of obtaining minerals because they get dissolved in water, right? Even we put fertilizer, once we put manure into plants, we have to water them because they get dissolved in water and absorbed by the plant. Therefore, water is an important solvent. So, if we give an example, salt is the solute. The one which is used in little amount is the solute, right? The substance that is dissolved in the solvent is known as the solute. So, salt and water, that is a salt solution, right? Salt solution. Then, once we take sugar and water, it becomes a what? Yes? It becomes a
Sugar solution.
Sugar solution. Right. If we take copper sulfate, yes, copper sulfate plus water,
Copper sulfate. Copper sulfate solution.
it's a copper sulfate solution. There we can use distilled water. It is available in the laboratory, distilled water. So we obtain a copper sulfate solution. Copper sulfate solution. Copper sulfate solution. Okay, you can take down the examples. So for the next week, I will give you certain presentation topics. Two students will get a topic. Then in each week, you will get topics alternatively. So all of you are going to do presentations, right? Yes, Sanaya.
Yes.
Yes. Okay. Who is missing? Shamla, are you okay? I think Ayan, yes, Ayan?
Nothing, miss. No, I didn't raise my hand or anything. What? Wonderful.
Hi. Have you all finished?
Yes, miss.
No, miss.
Teacher still.
Still writing. Okay.
Miss, I'm done.
Okay.
Miss, I'm done.
Please, I'm done.
Have you all finished? I think Sanaya and Kemi are still writing, and even Ayan. Okay. So once you have learnt a particular lesson on the day, you have to study it, because on the next day you will get certain questions out of these. So we will have continuous assessments. Assessments means not exams. We will just revise the things. So it will be helpful for you to remember the things continuously.
Excuse me, miss.
Yes.
Miss,
Cheros?
what a presentation, miss.
Presentation means, Cheros, I will give a topic. Actually, I will give 2 topics per week. So I will assign 2 students to make a presentation. Whatever the mode it is okay. You can use PowerPoint or whatever you like. So it should be restricted to a maximum of 3 to 5 minutes. Right? You can present it to the class, and then you have to ask 3 questions from the audience. Right? That's it. I will give the topic.
Okay.
Something simple.
And teacher.
Hari, have you all finished? Ayan, are you done?
Yes, ma'am.
Right. Then we will learn how to express the physical state, right? How to express the physical state. That becomes important when we are writing the chemical formula actually. So we use letter G for a gas, right? I will just mention it because in some of the books you will find this expression. So I will say expressing the composition of, sorry, not the composition, expressing the physical state. This becomes important when we start to write chemical formula, right? Still you are not familiar with chemical formula. So we use letter G for a gas, letter G for a gas, then L, simple L for a liquid, right? Then simple S for a solid, and AQ for an aqueous solution. Aqueous solution. Here it is thundering. Right, aqueous solution. Aqueous means aqua stands for what?
Water.
Water. So when something is dissolved in water, we call it as an aqueous solution.
Aqueous solution.
Aqueous solution. So I will mention an example in front of each. So what is carbon dioxide? Do you know the chemical formula of carbon dioxide?
Carbon plus oxygen.
Yes, Budhe. We express it as, have you seen we expressing it as CO2?
Yes.
CO2.
Yes.
So within brackets, here we will mention it as a gas. G, simple G is mentioned. Then water, what is the formula? Do you know? H2O. H2O. So here within brackets I put simple L to indicate that it is a liquid, right? Then I will say iron. Do you know the symbol used for iron? That is Fe. You may not know this, right? So I put simple S there since it is a solid. Then copper sulfate aqueous solution. On a copper sulfate aqueous solution. Copper sulfate aqueous solution. Copper sulfate aqueous solution. Do you know the formula of copper sulfate? Yes?
Copper plus.
Oh, we write it as CuSO4. Don't worry about this. I just wanted to show how we express the physical state. So here we put simple A, simple Q. Right? Copper sulfate aqueous solution. Right? Once you find these in books, now you know what is expressed. Carbon dioxide gas, both H2O liquid, iron solid, copper sulfate aqueous solution. Just note down it and remember.
Hello, fellow.
Yes, have you finished?
No, miss.
So we use simple letters or lowercase letters to indicate the physical state, right?
Done, Miss.
Okay. Have you all finished? Then we'll watch a video related to mixtures and solutions. Then I have to ask a question from all of you.
Sorry, Miss, I wasn't finished.
Tishu, we can't see the board.
You have finished it?
Yeah, Tishu.
I'm just writing the red stuff.
Okay, so now I have just finish it.
Done, Miss.
Done?
Yeah.
Yes, miss.
Right. Some are writing very fast, some are writing slowly.
I'm too fast, miss.
Shiroz, you write so fast, right?
Yes.
Yes. You Shiruz and Ayan are also from Qatar, am I correct?
Oman, Miss.
Oman, you're from Oman, right?
And Miss,
You are
where
from
in
Sri Lanka?
Sorry?
Miss, I'm actually from Sri Lanka.
Who? Ayan?
Ayan is from Sri Lanka. I am from Oman.
Ah, I thought Ayan is also from somewhere else.
Miss, even though I'm Sri Lankan, Miss, I was born in Oman.
Okay,
Ayan was born in Sri Lanka.
right. No. At the moment, both of you are staying?
In year 7, the same grade and same class.
Okay.
Miss,
Right.
we live nearby.
Yes, sir, Shiroz?
Miss, we live nearby.
Yeah, okay, good. Your friends.
Yeah.
Dandy.
Hello, fellow scientists. It's Justin here again, and I've got another problem that I'm hoping you can help me with. So I left my little baby sister alone for exactly 2 minutes, and somehow in that time she managed to almost completely fill her sippy cup up with sand and salt. Ugh, I can't let her drink that. But how do we get all the yucky stuff out of the water that she's supposed to be drinking? Well, to solve this problem, it sounds like we're going to need to investigate mixtures and solutions. By the end of today's lesson, you will be able to tell the difference between mixtures and solutions, and describe some different ways of separating mixtures. Let's get into it.
Woo! Adapted Mind Math! Come explore the site with me. I'm in first grade, so I'll pick that. Neato! A fun fishing adventure! Fish until...
A mixture is a combination of 2 or more different substances that each keep their identities. For instance, whenever you combine cereal and milk, you're making a mixture. And you can also clearly see that the cereal and milk keep their identities. They're still cereal and milk. The same goes for when you combine peas and carrots, nuts and dried fruit, and nickels, dimes, and pennies. These are all mixtures. Just please don't eat that last one, please. So what my sister was doing was creating a mixture in her sippy cup. She's a little scientific genius. Can you think of any other kinds of mixtures? Pause the video here and jot down your ideas in your guided notes. There are also different kinds of mixtures. For instance, what's the difference between this mixture of lemons and sugar and this mixture of lemons and sugar? In this mixture, the lemonade, you can't see the individual substances that were combined to make it. That's because lemonade is a solution. A solution is a type of mixture in which the substances are evenly distributed or spread throughout it. We can't just reach in and pull out just lemon juice or just sugar the way we can with some other mixtures. Some other examples of solutions include sparkling water, which is a mixture of water and carbon dioxide, or chocolate milk, which is a mixture of, well, chocolate and milk. Solutions are often made using different substances that are in the same state of matter, like food coloring in water. But you can also make a solution out of a solid and a liquid. Remember in a previous lesson about the physical properties of matter, we learned about solubility, which is the ability for matter to dissolve into other substances. Well, when a solid dissolves into a liquid, you get a solution. The solid that is dissolving is called the solute, and the liquid that the solid is dissolving into is called the solvent. Take salt water, for instance. Salt water is created when salt is dissolved into water. In this case, salt is the solute, or the substance that dissolves. Water is the solvent, or the substance that does the dissolving, and salt water is the solution. Try one for yourself. If you combine hot cocoa mix with milk, what's the solute and what's the solvent? Pause the video here to write down your answer in your guided notes. Solutions don't even have to be in the liquid state. There are solid solutions, like the copper and zinc solution that makes up brass. And there are gas solutions too, like the mixture of oxygen, nitrogen, and carbon dioxide that makes up our atmosphere. So, a mixture is a combination of different substances that each keep their identities. And a solution is a mixture in which the different substances are evenly distributed throughout it. But what happens when we don't want the mixture to be a mixture anymore? Like with that sandy, salty, sippy cup full of water that my sister made. Can I even separate out all the different substances to bring them back to the way they were before? Well, some mixtures can be separated pretty easily. Like, say, a fruit salad. If you wanted to separate that, you could just take your fingers and pluck out all the different kinds of fruit and separate them that way. It'd take forever, but it's easy. However, not all mixtures can be separated so simply. When that's the case, we can use the physical properties of matter to separate them. For instance, if substances in a mixture are different sizes, we can use a sieve or a sifter to separate them, like with this mixture of sand and gravel. The small pieces of sand will fall through the holes, and the larger pieces of gravel don't, separating the two. Similarly, we can use a process called filtration to separate solids and liquids. The liquids will move through the filter, but the solids cannot. You might see this process being used when your parents filter coffee grounds from their liquid coffee, or when noodles are separated from the water they were cooking in. We can also use physical properties like magnetism to separate mixtures. For example, how do you think we could separate a mixture of sand and iron filings? Sure, we could use a magnet to attract all the little bits of iron, leaving the sand behind. So far, all of our examples have been mixtures, but not solutions. Solutions are usually much more difficult to separate than other kinds of mixtures, but they're not impossible. One of the most useful physical properties to know when we're trying to separate a solution is the boiling point of each of the substances. For example, let's say we have a solution of water with solid sugar dissolved into it. We could just boil the whole thing on the stove. Water's boiling point is much lower than that of sugar, so the water will evaporate, leaving solid sugar behind. Also, you should know that some solutions will require more than one step to completely separate. And I think that's probably what's going to happen with my sister's water mixture. Now that you know more about separating mixtures and solutions, how would you separate a mixture of sand, salt, and water? Pause the video here and jot down some ideas in your guided notes. I think I'm going to start by taking the sand out first. I know that I can separate a solid from a liquid by using filtration, so I'll pour the whole thing through a filter, and that should separate the sand. All right, great. One substance down. But now we got to figure out how to separate the salt from the water. Why don't I just boil it? The water will evaporate, separating it from the salt. Woo, we did it. We've completely separated my sister's yucky water mixture. Now that we've solved that problem, let's review everything we've learned today. A mixture is a combination of two or more substances that keep their identities. A solution is a type of mixture in which the substances are evenly distributed throughout. we can separate mixtures and solutions by using our knowledge of the physical properties of the substances that have been mixed. To learn more about mixtures and substances and how to separate them, be sure to check out the activities and practice games for this lesson. You know, I am super glad that we learned as much as we did about mixtures and solutions today, but I think next time this happens, I'm just gonna get my sister a new cup of water. Thank you so much for joining me today, and remember, science is all around us. See you next time.
Okay, so it mentioned about mixtures and solutions. So what did you learn out of that? Yes, they mentioned something important related to a mixture. Yes.
Separating mixtures.
Told us how we
Separating
can
what? Yes.
just
Yes,
in
yes.
several ways. In several ways. For an
Yes.
example,
A mixture is made out of components. A mixture is made out of components. And we can separate the components in a mixture, right? A mixture is made of components and we can separate the components in a mixture. That's the most important lesson that we have to take out of it, right? Then after that we have to see what are these separation techniques, right? What are the separation techniques that we can use? Okay, we'll mention about that. A mixture is made of several components, or we can say constituents. Then the components in a mixture can be separated. Components in a mixture. Can be separated by physical methods. By physical methods. Let's see what are those methods. And a question. Seawater is a solution. Seawater is a solution. Is it a mixture? Explain your answer. Right. So you have to write an answer as you feel. After that, I will ask what you have written. Yes, you all have to write something.
Miss, what does it mean by the question?
Yes, it asks, Sanaya, It says seawater is a solution. Is it a mixture? You have to say yes or no. Then if you have said yes or no, you have to explain your answer. Why did you say so?
Okay, thank you.
Only Kemit, Shamla, Situli and me are from Sri Lanka, right? But all three of you are from the same area, I think, from Kurunagal, is it?
I'm Omani.
No. I mean Kemit, Shamla and Situli.
Yes,
Yeah,
teacher.
teacher, we go to the same school.
You have
Yeah,
the same
teacher.
school.
Uh-huh.
Here
Teacher
is,
Situli is in my class.
is it? So isn't it raining there at Kurunagal at the moment?
Teacher, it's almost flooding.
Flooding?
Yeah, teacher, it's raining and thundering.
Yeah, teacher, that's right. Teacher, they are full of water. And teacher, those trees are even like waving down and back and forth.
At the moment, but here the rain has not started, but it is thundering heavily, and the sky is dark, black.
Teacher, here
In Sri
it's
Lanka,
raining
miss?
heavily and thundering.
Yes,
In Sri Lanka?
yes, Cheros in Sri Lanka.
I don't know, like last 5 weeks ago, I went to Sri Lanka.
5 years ago, you have been here.
5 weeks.
5 weeks ago, okay.
Teacher, my auntie is in Qatar.
Okay. So, Cheros, do you have relatives here?
Like 34 relatives here.
Okay. Sana, you have a younger brother.
Yes.
Sadisha, you are also from Oman?
Qatar.
Qatar. So you and Senyuta from, do you know each other?
Yeah, we go to
Yes,
the same. Yeah, we in the same school and in the same class.
Okay, you are friends, right?
Yes.
Hari, have you finished writing? Did you build up an answer for this?
Yes, teacher.
Yes, it is.
Yes,
What did you write?
No, because if it is a mixture, we could see salt and water separately.
She says no. Right.
Teacher, it is.
Kemit says it is.
Teacher,
Sana,
can I
what
say
do you
ma'am?
say?
Teacher, can I say?
Yes, we'll ask whether it is a mixture or not first of all. Yes, Sanaya, what do you think?
We conducting.
Yes or no? Is it a mixture or not?
Teacher, it's a mixture. It is a mixture of not only salt, it's a mixture of various things. So that's why it is even it is conductive. It is electrical conductive. If it's not a mixture and if it's a pure substance, teacher, then it won't be conductive at the first moment. And teacher, seawater, normally we get salt from sea. Not sea from salt. We get salt from the sea, no teacher. So teacher, we get salt by by evaporating the seawater. So it is a mixture. It's a mixture
Right.
of various kinds of minerals and
Okay, that's Kemit's answer. What do you think, Sheroz?
Um, I think it's, I don't know this.
It's a mixture or a pure substance?
Mixture.
Mixture. Senyut?
Yes, it is, as it contains various things like dissolved salts, microorganisms, particles of clay and soil, bacteria, so it is a mixture.
He says it is a mixture. Sadisha?
Yes, seawater is a mixture because it contains dissolved salts, minerals, and more in the water.
Right. Shamla, what do you say?
Teacher, I wrote, yes, a seawater contains different components that can be separated, and a solution is type of a mixture.
Right. Okay. Ayan?
Yeah, it is a mixture.
It's a mixture. Right. Sanaya, you didn't give any answer yet.
It is a mixture.
It's a mixture. Right, yes. Seawater is a mixture. It is a solution. It contains lot of dissolved minerals and salts, basically. And in addition to that, nowadays, if we consider the seawater, it is mixed with a number of pollutants, right? Plastic, polythene, and a lot of other waste materials. Yes, Kemi?
Teacher, what about gallium? Because many ships, when it's break, and sometimes when the ship is leaking oil, teacher, gallium is released from the oil.
Yes, so many elements, compounds are added, and some of them are dissolved. There are oil. There is oil which is floating on seawater in certain areas, right? There are microorganisms, as some of you mentioned. It is a mixture of large number of substances, right? So I have heard in those countries like Oman, Qatar, Saudi Arabia, they make use of seawater since you don't have enough freshwater resources, right? You just
Teacher, they purify water.
Purify water. They use the method simple distillation in order to obtain pure water out of seawater, right? Is it true? Yes, those who are living there, do you know the method?
Yeah.
Yeah, right. So you can say your answer should be, is it a mixture? Yes. Yes. Seawater is a mixture of dissolved salts,
Teacher, in some countries they don't use seawater, but it's sort of using the seawater. They use the ocean as the energy sources.
Yes,
In
they
Sweden, teacher, they use because they doesn't have enough the sun energy and other all energies, so they use wave energy.
energy of sea waves in order to generate electricity.
Yes, teacher.
Right. Seawater is a mixture of dissolved salt, minerals, gases, waste materials, and many undissolved substances. Yes, seawater is a mixture. Seawater is a mixture. Seawater is a mixture. It is a mixture of dissolved salts, minerals, gases, waste materials, and many undissolved substances like plastic, polythene, rubber. Now you should be able to differentiate pure substances and mixtures, right? Pure substances and mixtures. What is the difference? So I will share the recording. So before the next week, next session, if you have missed certain parts, if you think that you have to watch the recording once again, you have to go through it and join, right?
Okay, Miss.
Done, teacher.
Harry, have you all finished?
Mhm.
Done, no? Then I am asking this question for homework. You have to think and join on the coming week. You have to come up with an answer. Homework question is, I will say that dissolving. That leads to our next lesson. Dissolving is a reversible process. What do you mean by a reversible process or a reversible change?
Can be
It can be
changed.
converted to its
Changed
original
back.
state.
Yes, you can take it back, right? You can just reverse the change that has happened. Dissolving is a reversible change. Do you agree? Explain along with an example. Right, you have to do this and join. Dissolving is a reversible change. Do you agree? Explain along with an example. Don't write this one, the one that I am writing here, don't write. Presentations, I will give 2 topics. So once you are given a topic, you have to do it on the coming week itself, because you are taking someone else's opportunity now. The others are waiting.
Excuse me, Miss.
Yes.
Is this for everybody for the presentation, or
No,
you just
only the ones that
random?
I have mentioned the name. So next time another 2 students will get the chance, right? Okay. Then I will mention another 2 names. You have to share the work done today. You have to share the work done today. You have to take photographs of your notes and send me through WhatsApp. That should be done by, yes, I will say, Senyut, you were there from the beginning, no? Senyut and number 2, Sanaya. 2 of you have to share the notes, so every day I will mention 2 names randomly. You have to share the work done on that particular day. Total, every day 2 of you have to share the notes.
Excuse me, teacher.
Yes.
Teacher, in the WhatsApp group, teacher, as I think we can message
Yes,
in that.
don't put them in the group. Just send me a personal message, right?
Okay, I'll do.
Shamla, did you get the topic?
Yes, teacher.
So be prepared, right? No, don't postpone. Once you are given, do it. Senyut and Sanaya. Where's Sanaya? You have to share the work done today.
Okay, miss.
Okay.
Right, so another 4 people will get the chance on the coming week. Right? Did you take down the things? Yes?
Yes, teacher.
All of you? Okay, so did you learn or did you enjoy the lesson today? Is there anything
Yes,
to be
teacher.
changed in the method of conducting the lessons? You can come up with suggestions.
No.
Is it
No,
okay?
teacher.
No, teacher. No,
This
teacher.
is okay, teacher.
Okay, for all of you?
Yes.
Right. Okay, then do the homework question. Study the things that we have done today. Those who missed, you can watch the recording once I share it. And two of you share the work done, and the other two be prepared for the presentations. See you on the next week then. Stay safe and have a nice time.
Thank
bye.
you,
Teacher, bye, teacher.
Have a nice day, teacher.
Have a nice day.
Bye, miss. Have a nice day, miss.
Teacher,
Have a
thank you.
nice day,
Bye.
miss.
Nice day, teacher.